So here we've got a quadratic, and you can tell from the form it's in that, if I just draw a terrible picture over here, so let's say it goes like this, and we can say this point here we know is HK. That point there is HK. Actually, I'll put it down here. So there we go, make that HK there, that's the vertex. All right, and why I'm drawing that is because we're given that at points P and Q we have tangents. All right, so find the x coordinates of the points P and Q such that the tangents have gradients m and minus m respectively. So if I make P the tangent of P here, so let's make that, that's the tangent, and that's at point P. And then let's make Q have, so let's make Q something like this. So that's Q. So I should have drawn them in line with each other horizontally, but okay. And then yeah, so we don't want to assume anything. And then the normal to P would be like that, and the normal to Q would be like this. So these are 90 degrees here, and you can see they intercept here and here. Okay, so let's have a look first. So we've got the equation y equals x minus h squared, so x squared minus 2xh plus h squared plus k. And of course, when we differentiate that, we get the gradient function. That's our gradient function, which is also 2 lots of x minus h. And we're saying that at point P, the gradient is m, and then at point Q, the gradient of the tangent is negative m. So I'm going to do both at the same time. So I want that to be plus and minus. What's x at those spots? Well, x minus h would be 2 plus or minus m. And then I'm going, oops. Let's try that again. So there we go. Plus or minus m divided by 2. And then x would equal h plus or minus m on 2. So you can see this x value at P would be, so we've got the positive gradient m there. So this is going to be h plus m on 2. And for Q over here, we'll put it h minus m on 2 as the x value. Now, if you sub those values in to here, so we can get our y value, you can see that if I sub it in for my x there, h plus, so you're going to have h plus m on 2 minus h all squared plus k. Of course, the h's cancel out, so you're going to have m squared on 4 plus k. So which one did I sub in? That plus, so m squared on 4 plus k. And if I sub in h minus m on 2 here and square it plus k, funny thing happens, h minus h cancels, you get negative m on 2 all squared, which is, negative squared is positive, so you still get m squared on 4 plus k. So m squared on 4 plus k. So they are at the same height, so that's good that we did draw them at the same height. Okay, so we've got these 2 points, P and Q, and we need to find the area of this quadrilateral that they make. So if you think about it, a couple of things. We know, if I keep that there, we've got I think the information we need. So we know that QP, so Q to P, all the way, that distance, if you think about it, we've gone from h minus m on 2 to h plus m on 2. So if this is h, we started at h, take away m on 2, and then we've gone to h plus m on 2. So that total distance, you can see, will be m. We've got 2 half m's there. So PQ, we know PQ to be the distance m, or QP is m. And we also know that OR, I've made this O and this R here. Why have I done that? Because let's say that's R, that's O, that's P, that's Q. If we want to find the area of that, we need those two lengths, because area equals of a kite is half xy, where x and y are the diagonals. So we've already got one of the diagonals. We know the horizontal diagonal is m. So we're just looking for the vertical diagonal. All right, so looking for the vertical diagonal. Well, we really need to find where these tangents intersect and where these normals intercept, and then we can have a look at those 2 points. So let's have a look at the tangents. So we're finding tangents. All right, let's find the tangent. So we've got y minus y1. So I'm going to do p first over here. So y minus m squared on 4 plus k. Oops. Equals gradient, so the gradient was m, and then we've got x minus h plus m on 2. So that's our gradient of our that is our tangent equation at P, and then, well, let's say, so that's tangent at P. Shall we do the tangent at Q? So let's do the tangent at Q. So we'll get y minus, now it's the same y value, we know that. And gradient's minus m. And then we've got x minus, and we've got h minus m on 2 here. So those are the two tangents. Now we do know that the tangents intersect at x equals h, where this, so we've got this nice symmetrical parabola, and the p and the q both lie on the parabola, and they're at the same height. So we do know that the tangents are going to cross right in the middle at the axis of symmetry, and we know the axis of symmetry here is x equals h. So we could just use that. We could just really use one tangent. We don't really need both tangents. We could just say, let's use that one tangent and look at what happens when x equals h, because I know that is where they intersect. And we really just want to find the y value. So when I put x equals h in, what do I get? I get y equals, I'm going to this side first, and then I'm going to put this on the other side. So I've got m. Now if I put h in here, I'm going to get h, take away m on 2, and then add this bit to the other side. I'm going to get m squared on 4 plus k when I add that there. So you can see those h's are going to cancel, and I'm going to get negative m squared on 4. This is the same as negative 2m squared, on 4. I'm just making it on 4 because I need to add that, and it makes it easier for me. So I actually get k minus m squared on 4. Alright, so k minus m squared on 4 is the height of where that intersection happens. So that's at h across and at k minus m squared on 4 in height. I hope you can follow my picture. Alright, so if I do the same for the normals, so this, I'll just pick one, let's say the normal, again, let's just do the normal at P. So we are going to get y minus, again, y1 equals gradient. This gradient will be negative 1 on m because it's perpendicular to m. And we've got x minus h plus m on 2. So y minus y1 using point P equals gradient, so the normal gradient, x minus x1. And again, so if I sub in x equals h, what do I get? I get y equals negative 1 on m. Alright, I'm just going to do it in our heads here. So this is h minus h, so that cancels, and then we've got minus m on 2. So here we've got minus m on 2. So you can see the minuses are going to cancel, and the m is going to cancel, and we've just got a half. But we need to put this on the other side as well. So we're adding m squared on 4, and we're adding k. So altogether we're getting a half plus m squared on 4 plus k, and that's going to be the height of this point up here. We know it's h as its x value, and here is its y value. All right, so now if we're looking for that distance, because we just want to find that distance OR. Did I write that? I hope I wrote that down. All right, so we want the distance O to R, and you can see it's going from k minus m squared on 4 all the way up to half plus, so it's going, so we want to look at half plus m squared on 4 plus k and subtract k minus m squared on 4. So that's the differences in the y values. So what do we have then? You see the k's will cancel, and we've got m squared on 4 plus m squared on 4. So we've got a half plus 2m squared on 4, which is just a half. Did my k's cancel? K minus, I think they did. All right, so let's say hopefully we're correct. Half plus m squared on 2. So if I put that over here in this formula here, I'm half times, or half plus, sorry, m squared on 2. Actually, I might factorize by half, so let me do it in blue over here. So I've got half m, and I'm going to put half outside of 1 plus m squared. So that makes it easy because I can see it's a quarter m times 1 plus m squared. Or I could say m on 4. You can put that any way you want, really. So that's going to be my area, unit squared, of that quadrilateral formed.